Have you ever tried to count a really large number of something, like a huge pile of pebbles or a vast flock of sheep? Our early ancestors faced this exact challenge, and it was a surprisingly tricky problem to solve. Before numbers as we know them, they might have used simple one-to-one matching, like one pebble for one sheep. But what happens when you have hundreds or thousands? Ancient civilizations developed number grouping methods, often called base systems, out of sheer practical necessity. They wisely shifted from that tedious one-to-one counting to organizing items into larger, predefined sets. This brilliant innovation made dealing with large quantities much more manageable, laying the fundamental groundwork for all modern mathematics. The primary reason for this shift was the inherent limitation of one-to-one correspondence. Imagine trying to count to 173 sheep by carving to 173 separate notches on a stick. It would be incredibly time-consuming, prone to errors, and difficult to remember or communicate. Grouping simplifies both memory and recording. If you have 10 notches, you can erase them and draw one larger mark for 10. This makes mental calculations easier and helps in trade, record keeping, and even building large structures. The base system acts as a natural mental shortcut, reducing the individual items you need to track. To create these grouping systems, ancient cultures typically looked to what was readily available: their own bodies. The most widespread method became the base 10 system, which is what we use today. This makes perfect sense when you consider that most people have 10 fingers and 10 toes. It is intuitive to count up to 10, then designate that group as one unit of the next order. However, other bases also emerged. The Sumerians and Babylonians used a base 60 system, which survives in our measurement of time with 60 seconds in a minute and 60 minutes in an hour, and in geometry with 360 degrees in a circle. The Maya civilization famously used a base 20 system, likely because they counted both fingers and toes. These early number systems were more than just tally marks. They were sophisticated tools reflecting deep cultural understanding and environmental influences. The base 60 system of Mesopotamia, for instance, offered superior divisibility, meaning it could be easily divided by many smaller numbers like 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30. This was incredibly useful for trade and calculations involving fractions. The Mayan base 20 system, combined with their concept of zero, allowed for incredibly complex astronomical calculations and a sophisticated calendar, far more advanced than many European systems of the time. This move from simple counting to abstract grouping was a monumental intellectual leap. Ultimately, the development of number grouping methods was a story of human ingenuity driven by everyday needs. It was about creating practical systems to manage resources, organize societies, and build magnificent structures. By adopting these base systems, our ancestors didn't just count better. They built the very foundations for complex societies and all the scientific and technological advancements that followed. This clever shift from counting individual items to bundling them into groups truly transformed how humanity understood and interacted with the world around them.
If you love exploring numbers, like, subscribe, and keep counting with us.